children. Today you are going to learn about symmetry. This chapter you already learnt in your previous class. So first of all, what is a symmetry? Symmetry is nothing but if two or more parts of a figure are identical after folding or flipping, then it is said to be a symmetry. So now, for example, if I take this sheet, if I want to fold like this, see, I am folding exactly to the middle. I am folding exactly to the middle. So, now what happened if I open? This part is completely overlapping on this part. So, when I fold, the first part is completely overlapping on the second part. So, such type of figures are called as symmetrical figures. For example, if I fold it here instead of the center of the paper. Now, if you observe, this part, this first part is not completely overlapping on the second part. So, such type of figures are called as asymmetrical figures. So, when the figure completely overlaps on each other, then such figures are called as symmetrical figures. When they are not overlapping completely on each other, such figures are called as asymmetrical figures. Now, if this is a symmetrical figure, so here when I fold like this, then you are able to observe a crease here. So, this line is called as line of symmetry. This line of symmetry might be a vertical line, or if I fold like this, then it is a horizontal line of symmetry. This line is called as horizontal line of symmetry. So, what is a line of symmetry? A line of symmetry is an imaginary line which divides an image into two equal halves. Such type of figures are called as, such type of lines is called as line of symmetry. So, for example, if I draw a square here, okay, now I am drawing a line like this. So, this dotted line is mean that it is an imaginary line. So, here this is also a line of symmetry, which this is a line, it's an imaginary line which divides the image into two equal parts. So, this line is called as line of symmetry. So, a line of symmetry, it might be a horizontal line or a vertical line. You all know about regular polygons. Regular polygons are having symmetrical shape. They are of symmetrical shape. Why? Because they are of equal lengths. So, all the regular polygons have symmetrical length. I told that all regular polygons are symmetrical in shape. So, the first example, it's an equilateral triangle. If you take an equilateral triangle, then you can draw a line of symmetry like this, and one more is like this, and the other is like this. So, for an equilateral triangle, you have three lines of symmetry. If you take for a square, you have four line of symmetries. See, this is 1, 2, 3, 4. So, for a square, you have four lines of symmetry. If you take a circle, wherever you draw a line, that is an identical line. So, these are all lines of symmetries only. So, for a circle, you have infinite number of lines of symmetry. For an equilateral triangle, you have three lines of symmetry. For an square, you have four lines of symmetry. And for a circle, you have infinite lines of symmetry. Now let us see types of symmetries. You have two types of symmetries. types of symmetry. One is reflection symmetry. And the other is rotational symmetry. So, first we will see about reflection symmetry. What is a reflection? Generally you will see in mirror. You will stand in front of the mirror. What will you observe there? You will observe your image in the mirror. That is called reflection. So that is a reflective symmetry. See, for example, now here I have drawn a flower. See, this is a line. Here there is a line. In the middle there is a line. So this line, when it is, see, the other half of the figure is not here. So to get this half of the part, so first draw the figure of half of the part and just fold it like this, and then on the crease you just need to do like this. Rub on that figure. Then you are able to see the image on the other side. That image is reflection of that particular object. So now if you draw the figure, you are able to observe a dim colored figure here of the same image. So if you draw on that, then this is the reflection of this figure. Now the reflection of this image, whatever is found here, I drew it this side. Then see, if you observe the figure, the reflection is same. This is the original figure and this is a reflection of the figure. So when you observe the figure, both are identical. So this type of figures are called as reflection symmetrical figures. Now the second type of reflection is rotational symmetry. So now, what is a rotational symmetry? If a figure rotates at a fixed point, then that point is called as center of rotation. When you rotate a figure with a fixed point, then that point is called as center of a rotation. It could be a clockwise direction or anti-clockwise direction. See, this is a figure. Now if I rotate like this, this is clockwise. And if I rotate like this is anti-clockwise. The rotation might be a clockwise or anti-clockwise. And I am rotating with a fixed point. So this point is called as the center wherever it is. It is called as center of rotation. And see, for all the rotations, you have an angle of rotation. So, what is a complete angle? Complete angle is nothing but 360 degrees. Complete angle is nothing but 360 degrees. First, I will show you how you need to rotate an object. Now, how you will find what is a rotation symmetry. Say, for example, if I take the duster like this. I am placing like this. First the duster. The position is like this. So this is 0 degrees position. 0 degree position is like this. Your duster position is like this. Now I am rotating like this. I am rotating in clockwise direction. So now I am rotating like this. So your second position from here to here. This is like this. This is 90 degrees. Now I am rotating like this still. So this is 180 degrees. So now your duster position is this. Now I am rotating like this. So this is 270 degrees. Your duster position is like this. This is 270 degrees. And now again I am going to the original position, that is here itself at 360 degrees. So now when I rotate this object, how many times the object appears same as your original figure? Then that is called rotational symmetry. See, what is a rotational symmetry now? Here, how many times your figure appears in the same manner? This is the, see, first when I rotate, this is a 0-degree position. First it is in the 0-degree position. So when I rotate like this, it is rotating like this, which is not identical to your figure. So now when I come to the other rotation of 180 degrees, then it is identical to your original position. So here your rotational symmetry is 1. Now when I go to here for 270 degrees, your position is not identical. Now again when I come into 360 degrees, your position is identical. So here it is second time. So what is the rotational symmetry of this particular figure? It is 2. Order of rotation is 2 for this particular figure. Now I am going to tell you one more example for rotational symmetry. For example, I have taken a square like this and I am fixing a point P here. So this P just for your rotation to see, and I am representing it there, that's all. So now let us see what is the rotational symmetry of this particular figure. So first your figure position is this. Here is a P. So it is at 0 degrees now. Now when I rotate it to 90 degrees, your figure is like this. So your P point is here. It shifts from here to here as I rotated 90 degrees. Now again when I am rotating to 180 degrees, your figure will be like this and your P point is here. This is at 180 degrees. So from here your point moves to here, that is 180 degrees. Now again I am rotating to 270 degrees. So your figure will be like this and your point will move to here, and again when I go back here to your 360 degree angle, your point P lies here. So what is a rotational symmetry? Rotational symmetry is the figure, whatever you are rotating, how many times it appears identical. That is your rotational symmetry. So now first when I move from here to here, your figure is identical. So this is 1. And when I move from here to here, your figure is identical still. So this is 2. Now when I move from here to here, the figure is identical. It is 3. When again it go back to 360 degrees also, your figure is identical. So it is 4. So what is the rotation symmetry of this particular figure? It is 4. Now I have shown you 2 examples. One is for the duster. It is the order of symmetry is 2, and for the square the order of symmetry is 4. So now let us find angle of rotation. So you all know that the complete angle is 360 degrees. So for the duster, the first object what we have taken as a duster, the order is 2. So what is an angle of rotation of that? So you need to divide 360 degrees with 2. You need to divide the complete angle with your order of rotational symmetry. So the angle is 180 degrees. So for the duster, the angle of rotational symmetry is 180 degrees. Now for the square, it is 360 degrees by 4. So the angle is 90 degrees. So for the square, the order is 4. So the angle of rotational symmetry is 90 degrees. In this way, you will find the angle of rotational symmetry. Now, I told you the center of rotation. So how will you find what is the center of rotation? Where it lies? See, for example, if I draw a square like this, if I join these diagonals, so the center where the diagonals meet, that is called the center of rotation. Center of rotation. Now, you have learned two types of symmetries. One is reflection symmetry and the other is rotational symmetry. See, for all the figures, all the images, you have a line of symmetry and also a rotational symmetry. But for all the images, you don't have all line of symmetry and the rotational symmetry. For some images, you have line of symmetry and rotational symmetry, and for some you have only a rotational symmetry, and for some figures you have only a line of symmetry. For example, if you take H as a letter, then for this letter you have both line of symmetry and also rotational symmetry. See, this is a line of symmetry for this figure and it has a rotational symmetry. This is the original position H, and if I rotate, it becomes like this. And next if I rotate, it becomes like this. And next if I rotate, it becomes like this. And next it comes to the original position. So here the order is 2. This is 1 and this is 2. So the order is 2. So for this particular letter, you have a line of symmetry as well as a rotational symmetry. For example, if you take a tree like this, it is having only a line of symmetry, not a rotational symmetry. So, all the images are not having both line of symmetry and rotational symmetry. For some images, you will have only a line of symmetry, and for some images, you have a rotational symmetry, and for some, you have both line of symmetry as well as rotational symmetry.